Hello, everyone, and welcome to Tech Day Pakistan 2024 event. This is our third year for hosting this event, online event, and we have over around 27 sessions today, and in three different rooms. And I welcome you all to the Code Space Arena room here. And today with me is Hamish Watson, and he will be delivering session on a new paradigm of the cloud engineering, empowering DevOps processes with AI. So over to you, Hamish, and you can introduce yourself and take it from here.
Thank you so much. And look, it's a real pleasure to be part of this event in its third year. So thank you very much for allowing me to present today, and hi to everyone that has joined. Alrighty, g'day, or hello, I should probably say. I'm Hamish Watson. I'm a DevOps consultant based here in Christchurch, New Zealand. And I think one of the greatest things that links New Zealand and Pakistan is our love of cricket. And just before this session started, I was talking to Adnan around, some cricket talk. So I hope to one day visit Pakistan because it's on my checklist of places to go.
We welcome you.
Look, look, I've been doing this ones and zeros technology stuff for 25 odd years now, and putting that down actually makes me feel quite old. DevOps is something that is near and dear to my heart, because for me DevOps is a methodology of helping people deploy their code faster and better. And so one of the reasons why I do these community events is hopefully, at least one thing that I talk to today helps enhance your work life. And if it enhances your work life, then it's going to enhance your home life, because you'll be automating things instead of deploying them at 3 in the morning. I do run my own business, Morphit, and part of the drivers for that is helping people understand AI, data, and cloud platforms. If I summarize who I am in one sentence, I am a technologist. I absolutely love technology. But more importantly, I understand business value, because as much as I want to, play with technology and create things, at the end of the day, we all need the end game where someone pays for what we're doing, or pays us. If you follow me on Twitter, you'll know pretty quick that I have a hashtag that I made up some time ago, which is make stuff go. And that's the premise of how I live, in terms of every day. I carve my day up into incremental chunks and, go through those things. And at a technology perspective, I help clients realize the benefits of DevOps, reliable and repeatable automated delivery of business value. Anyway, the agenda for today, I'm going to introduce a little bit around DevOps. I'm going to introduce where AI can help. I'm going to talk about some examples of tooling, and I guess the caveat that I have here is that I'm not actually promoting these tools. I'm not actually paid by any of these companies to sell those tools. These are just tools that I've found over the years have helped myself and people I've worked with in industry. So I'm not, on selling these tools at all. They're just examples. We'll do a quick summary of what I've talked about, and then we'll do a Q&A session at the end. So what the heck is DevOps? Well, DevOps was very succinctly described by Donovan Brown, who sadly has retired from Microsoft. But Donovan spent a number of months coming up with what is DevOps in a sentence. And we have this quote here where it's the union of people, process, and products to enable the continuous delivery of value to our end users. And one of the reasons why I put this slide up is because it resonated well, because I was actually kind of talking about the same thing way back in 2012. Donovan's quote there was from, I think, around 2016. One of the issues I had back in 2012 was DevOps was only around for about 3 odd years, and we were only, cloud actually wasn't something we were deploying to at that time. We were still doing thing on premises. But myself, as a operations manager, when I was working with development teams and trying to form the basis of what a DevOps team would be, we argued so much on what DevOps was. So I came up with this, where we're using our tools, we're creating a process that allows us to automate the reliable deployment of business value to our clients. And I guess that's a key thing I want to call out for this session, right? This session's around how to deploy things using cloud engineering and AI. But at the end of the day, we have to remember that we want to deliver business value. Our clients don't really care about the ones and zeros. They don't care about, the efficiency that we can create in our code, or the indexes and queries that we tune within our databases. They literally just care about the business value that we deliver to them. And I think that's a great, benchmark for how we interact with both technology and our co-workers. The funny thing is, about 2 years later, I came up with the hashtag Make Stuff Go. And one of the reasons why I came up with that was the last sentence, this one here, was a bit wordy. Whereas literally when I was working with development teams, when I was working with QA engineers, or even when I was working with sales and marketing, because if we talk about the breadth of DevOps, we do actually need to consider people that work in sales and marketing, because they're in touch with with an industry. They're in touch with what the trends are in terms of what features we might need to put into our value that we're delivering to people. And so I came up with this: make stuff go, right? 3 words, join them together, and whatever we do, whether it be cloud engineering, quality engineering, or platform engineering, whatever, does it make stuff go? And for you, my audience, if what you're doing each day, does it make stuff go? And I would like to put after there reliably, faster, but it'd be too wordy. Anyway, let's have a quick look at how the industry used to be. And I feel like this is somewhat outdated, because I'm hoping that this scenario doesn't happen for you. But the sad thing is, it still does happen with companies out there. And so what we have here is we have a request to provision an IT service. Now, that IT service could be an app service up in Azure. It could be an EC2 instance running in AWS, or it could be a BigQuery data set running up in the Google Cloud Platform. But what we've got here is, all through this, we've got requests that are handed off, handed off, handed off. And all of these things introduce time, they introduce toil, where we're doing things, manually and not in a scalable fashion. And so we want to get away from this. And the new way of provisioning things should be something like being able to codify what we're deploying, being able to codify the change request that we have to raise. Because whenever I talk about the new way of deploying services, infrastructure in cloud or on premises, the first thing people say to me, oh, so you don't want to do change requests, you're trying to get around auditing. Absolutely not. In fact, it couldn't be more so. By codifying what we are doing and using artificial intelligence in terms of the checks and everything, we're actually auditing and having more checks within our delivery pipeline of value than ever before. And I'll give you an example, and I really wish I'd done a screenshot of this right now, but I will codify within GitHub Actions, right? I will codify all the checks that will check to see if a change request is created. And so one of the things, the prompts is put in your change request number. It'll then go and look at that change request to make sure that everything is okay there. And if it's not, we're not deploying. And that actually changes the dynamic, because I don't know about you, but here in New Zealand, we have a thing called a change approval board, where you have to go along and produce all the evidence of, what you're doing. And normally it's like 20 pages of Word doc, and I hated it. And I was like, how can I automate this? And first of all, I codified it. Second of all, fast forward 10 odd years, I'm now using some of the AI processes within GitHub Actions in Azure DevOps to actually go and check all those things. And a lot of the time I'm writing in YAML to produce those things, because if I flip between, say, Azure DevOps and GitHub Actions, often the paradigm of being able to write in YAML is very similar. Alrighty, so let's talk about the current pain points of building cloud platforms. And historically, this was a manual process. Back in the day, we would, if we look at on-premises, we would put in servers, physical servers, configure them, and then, hopefully we'd be running some scripts and everything. And as we moved towards the cloud, that paradigm was sort of still the same, where people were provisioning it either through a portal or user interface. They would run some scripts manually, and even though, say, the VM was now in the cloud, or even an app service, say, or even a database, the fact that we were doing it manually, that is not scalable at all. And of course, the cost, right? Because if we're doing things manually, it's hard to scale people without incurring some form of cost. And the availability of people, since we're doing things manually, we might have our applications may spike. And normally applications don't spike or, want more resources when it suits us. It's normally, middle of the night. And so these are all issues that we're facing. The number of times where I talk to people and, we look at what monitoring they have, and often they don't have any monitoring in place. Or if they do, no one's checking it because there's so amount of noise coming through, like often, we will want to have our logging, and hopefully everyone is doing diagnostic logging within your applications and data platform. We may have debug set, right, in terms of our level of logging. Well, there's so much noise. We really only want to know about the errors that are occurring. If there are errors, then we do want to go and scan through all those diagnostic logs. But again, how do we do that? And inconsistency. Sadly, we're humans. I may be deploying some service. I deployed it yesterday, all good. I go to deploy it today, my phone rings, my child, my friend, maybe even my boss wants to talk immediately while I'm deploying something manually. And what happens is, even though, setting up services within cloud platforms is so easy-ish, if I'm distracted while I'm actually deploying that manually, I'm not going to install it or configure it as consistently as I did yesterday. Whereas from my perspective, I want to introduce, one of the true tenets of DevOps. And what we have here is, we have a data engineer, we have app developer, they're developing code, right? So the app dev may actually be doing the infrastructure here, by the way. But as they're writing the code, they're writing unit tests as they go. We push that up to source control. It's built. We'll have build tests, and we will deploy it to a tiny little build environment. And the cool thing is, and I've put Kubernetes here because we might actually want to deploy it on-prem. We hopefully are containerizing it, but we want to get immediate feedback. And if it passes here, then we want to deploy right throughout our application stack in terms of our platform. We might push up to an integration environment, functional test environment. And when we get to user acceptance, we might actually let the humans on it. And all the way through here, we're provisioning these systems using code. And if it passes all through these, then we will deploy through our pre-prod and production environments. Now I've got continuous testing here, and one of the things I introduced to my clients is the fact that we now have at our disposal in the last 3 years, it's been a game changer. We can actually use AI processes in terms of analyzing all of the diagnostic logs, all of the testing logs that has been brought back right through our deployment or delivery pipeline. And all of these environments are all deployed from the same code base. Yes, we will have different variables. We will, we'll optimize for production, whereas build, integration, functional test, they're tiny little systems, but the same structure, security setup will all be the same. And using, tools like Snyk, using tools like checkmarks, in terms of the AI processes that are built into them, we can ensure that every environment that we are deploying is 100% consistent and validated against what we will deploy to production. Alrighty. So AI in terms of cloud engineering and DevOps. And I guess if I look at it, this is an integration where AI is allowing us to have predictive analytics and automation capabilities, which will complement the scalability and flexibility of what we know as cloud. When I think about when I first interacted with cloud back in 2014, which is, goodness, almost a decade ago, I was amazed at what I could spin up and, more importantly, scale in cloud that I could never, ever, ever do, on premises. It was amazing. But the problem is that, I'm using someone else's computer or server, and so they want to charge me for that. And so very early on, I realized that I needed to look at how I could enhance what I was running so that when there was no usage, when we're going to use the minimal amount of resources, but when that peak usage comes on, we'll scale up. And, looking back, 10 years ago to what we can do now in terms of auto scaling on the Azure platform, it's an absolute game changer. And the fact that Microsoft are, putting so much effort into, artificial intelligence and machine learning behind the scenes so that I can codify how my application is going to scale, and being able to manage my resources far more efficiently, it's it's amazing. And I can't believe what I do know what I used to do. I had so many scripts that I would run to ensure that things were okay. Well, I don't have to do that anymore. It's baked into the platforms. And problem solving, you know, if we look at problem detection and resolution and how we can feed that into optimizing the performance of our platform or apps or whatever we are running on, a cloud platform, the fact that we can not only automate the problem solving in terms of if something happens, then we'll do this. It also allows us to ensure that we have compliance in terms of security within our cloud environments. And that is vital for us when we are running applications, databases, infrastructure on a cloud platform, that we do comply with security and that we continue to look and optimize what we are running up there. One of the key benefits that I see, that I've used and see with AI is that they can identify patterns. They can predict potential issues before they become critical. And they can suggest, or if we allow, they can implement solutions without human intervention. And this is so true of all cloud platforms. I am, a Microsoft MVP. So my cloud platform of choice is Azure. But as, a business person, I will work with clients in terms of what cloud platforms they want to use. So sometimes it's AWS, sometimes it's GCP. But the cool thing is that I'm definitely enamored in terms of what Microsoft are doing on the Azure platform in terms of incorporating AI. And, if you haven't heard of Copilot yet, you will hear more and more and more of it. And it is a Copilot. It is something that is next to us, looking at all the things that can help us speed up our delivery and allow us to innovate like we never have before. And I really think the convergence of AI, cloud engineering, and DevOps really helps us foster an environment or a work life where we are looking at continuous improvement and innovation, because we can utilize AI in the background to give us information from all of the data to help us make better decisions. We can streamline our workflows, and this flows into how we will deploy our cloud services and applications. And if we utilize AI in terms of provisioning environments, from the get-go, like literally on my laptop, right? I use Visual Code. I have extensions within Visual Code for when I'm writing Terraform that it's checking that my formatting, my linting is correct and won't cause issues. I do use a SNCC extension within Visual Code, and that is checking from the get-go that, I'm not introducing any vulnerabilities into the code that I'm writing, definitely at an infrastructure as code level. And then utilizing check marks in terms of an extension for any application code that I write or developers, application developers are writing. AI is analyzing our user behavior in terms of our code. It's ensuring that we're writing secure code and compliant code. Whilst also further along our pipeline, we're ensuring that we have application performance. And as we go further up the stack, that we have insights driven by AI and machine learning that enable us to innovate, test it out. If it doesn't work, we throw it away because it's just code at the end of the day. All the resources we've deployed on our cloud platform of choice came from code. It's just literally a branch that we've branched off. We try some stuff out. We use AI in terms of compliance, testing, performance, monitoring. If it doesn't work, throw it away. That used to be months of work. Well, now it can be minutes to hours of work. Automation. So AI algorithms, and I speak specifically to the Azure platform, can dynamically analyze our application performance, and also our user demand in real time. And if we choose to, it can automatically adjust our resource allocation to meet those needs efficiently. We can also put some boundaries around that so that if, you know, we don't want it to scale right out and cost us thousands of dollars per month, but we do want it to be able to react and adapt in an intelligent manner, especially at 3 in the morning. And of course, we want to streamline our deployment process by automating the configuration of our cloud environments. And so we can utilize AI in terms of optimizing our configuration settings based on, specific requirements. And, we can point it at historical performance data. So this allows us to accelerate our deployment process, right? But also ensures that our deployments are error-free because we have all these checks put through that normally, would just be too hard to do. Like, gone are the days where I have to wait for quality engineers to be available to do all my manual testing. At which point, I imagine someone out there is asking, well, if you're having all this AI automation stuff going on with the tests, did you fire all the quality engineers? No. What used to be known as a quality assurance engineer, I now think of as quality automation engineer, because we actually need people who have a testing mindset, who can write the automation. And so it's a blending of myself as a DevOps engineer or cloud engineer or platform engineer, whatever you want to call it. It's a melding of minds in terms of a common viewpoint of how we will deliver business value. And so, in fact, I need quality engineers who understand automation, because we have to write the automation, right? I'm not automating myself out of a job. I'm automating all of the bad things that make my job horrible. And of course, predictive maintenance, right? So, I think of this along with the next section, self-healing systems. And so we will utilize AI algorithms to analyze logs and look at massive amounts of monitoring data so that it can predict potential system failures or performance bottlenecks before they actually occur. And it can, initiate preventive measures and automatically apply fixes. And this is true of most cloud platforms. And I think of the self-healing solution within Azure for app services. So if your app service, has an excessive amount of 500 errors, so HTTP status go to 500. If we're having, a lot of those within a short amount of time, there's obviously something going wrong in our app. It's got a real unhandled exception. And utilizing AI within our environment to look at that and to self-heal, and sometimes it may require either bouncing of that app service or configuring something. It may be that we don't have enough resources, right? So instead of 2 web services, we might actually need 5. Well, the key thing here is it's avoiding downtime and it's maintaining optimal performance. And we want to reduce the operational burden on cloud engineers so that we don't have people getting up at 2 in the morning, 3 in the morning. It means that we can improve the overall uptime and reliability of our cloud-based apps and services, and which means that our cloud engineers can move from that operational mode where we're like getting up and resolving things to an enhancing mode, a higher level form of activity and how we work. And of course, I can't talk about cloud platforms without talking about security, right? And so one of the things we want to do is look at predictive threat detection. And so again, AI can analyze, our historical and real-time data from various sources within the cloud environment to identify patterns and behaviors which may indicate a potential security threat. And when I look at some of the things associated with security, we need to look at a lot more than just our application. We need to look at, the compliance of the underlying infrastructure below. We need to look at the security of our networks. We may have virtual networks set up. Do we have the right security groups set up? Are they robust? Are they doing what we want? And so this predictive threat analysis or detection means that it's proactive as well as predictive, because it significantly will reduce our breaches and ensure, the continuous protection against evolving cyber threats. Because, as much as we want to, deploy the latest and greatest, we do need to consider that, our threat actors out there are doing the same. They're evolving their code to try and break in. And of course, automated response, using, AI in terms of detecting potential threats. We can instigate automatically, we can instigate an automated response in terms of what that risk may be. And so this might be isolating effective systems, deploying patches immediately, or adjusting, firewall rules to block malicious traffic. And, I do come from a situation where I've built infrastructure with security in mind from the onset. I will always put a web application firewall in front of my applications. I will always use managed identity instead of, hard-coded authentication to, to a database. And so having AI in terms of how we will respond, being able to devise some of that into our architected solution means that, the incidences are addressed immediately. We have certain rules around what may or may not happen. And again, that's because we have lifted our game in terms of how we are cloud engineers, because we don't have to do the manual toil. We don't have to do the operational investigation and resolution of things. We can now actually go up a level and start engineering true automated responses into when things happen. And of course, this means that we are continuously working on how we're monitoring our cloud environments. We allow automation and AI to enforce security best practices, such as ensuring encryption is used wherever necessary, our access controls are properly implemented, and our configurations are secure. And again, we can do that early on in our pipeline, right? So that can happen immediately on my development environment or on my laptop, because all the way through our engineering pipeline for cloud resources, we're using the same code base. And of course, vulnerability, right? So we can automatically scan the code at source. We can look at dependencies and also our infrastructure as we move up for known vulnerabilities. And again, we're going to use machine learning to identify patterns indicative of potential security threats. And, we can prioritize these threats based on their severity, what they might exploit in our technology stack, and also the potential impact on the overall system. And again, this gives us a sort of, I don't know, like a checklist or shopping list of things that, we need to fix first. And those things are the most critical ones first. And so this reduces our window of exposure, but also optimizes, the allocation of our security resources so that our efforts are concentrated where they're going to have the greatest impact on improving our overall security posture. which, you know, if I think about me as a person, that is something that I could not do, right? Looking at the whole scheme of a application, you know, in terms of, you know, the firewall at the front, the app services, some cache servers, say Redis, you might have Databricks in there in terms of your analytics. You might be using some form of database, say Azure SQL database, as well as your VMs. You know, that is 100% somewhere where we need to utilize artificial intelligence and machine learning to manage the critical aspects of our stack. DevOps. I couldn't talk about DevOps without talking about CI/CD, so continuous integration and continuous delivery. And where we have AI really helping, and I know that I may be repeating myself here, but we want to automate routine tasks and optimize our processes. And we want to utilize AI in terms of looking at our historical data, as well as getting that real-time feedback. And you saw that in my animation before, where we're getting feedback all the way through our deployment pipeline. Well, we need to run something over that to be able to get all this massive amount of data and bring it up in terms of information. And so that will allow us to, you know, optimize what we're doing. And so, you know, using machine learning, we can predict the best time for deployments. We'll identify, you know, bottlenecks in our development processes, and more importantly, suggest improvements. And so combined with this, you know, and I've talked about this before, is before we have our changes merged and deployed, AI is going to analyze our code and infrastructure changes to predict their impact on our system. So we can see our potential failures or performance issues way early in our deployment pipeline. Gone are the days where we're just going to find this out in production. We're going to find it out in our build environments, our functional test environments, or wherever. And, you know, we'll dynamically allocate our resources through that pipeline on the needs of the development and, you know, the deployment processes. We'll look at the workload and performance data. So we'll scale resources up or down. And that's an important one, because we may want our resources scaled up during a test phase. We want them either scaled down or maybe even destroyed when we're not testing. And so we're going to have, again, algorithms and machine learning in the background that is continuously scanning the resource allocation and usage. And if it doesn't require to be there, it's gone. You know, AI plays a crucial role in monitoring cloud services and infrastructure, because we're going to employ advanced machine learning algorithms to detect anomalies, you know, in real time. Not 2 days later, but right now. And, you know, I look at tools like Dynatrace and Datadog, which analyze metric logs and traces to identify deviations from normal behavior, right? And so we might have unexpected spikes in traffic or resource usage. Well, we can have immediate alerting on potential issues before they even escalate, which enables us to have quicker response times and minimizing the impact on service performance, especially in production. And of course, you know, Dynatrace can automatically perform root cause analysis to determine source of problem, whether it's in, you know, our app code, infrastructure, or some other specific service dependency. We may have an issue in our cache servers. And so by pinpointing the exact cause of an incident, you know, trawling through all the data, these tools significantly reduce the time it takes to resolve issues. Now, I've called out 2 tools here, Datadog and Dynatrace. I'm not saying that you should buy them or look at them. I'm just saying that these are tools that I have used with, you know, good success. And of course, this feeds into continuous optimization and performance tuning, because, you know, AI not only detects and responds to instances, but also contributes to our continuous optimization of our cloud resources. So a couple of case studies, Netflix has always been a really good one. Way back in the day, they had their chaos engineering department. And so, what is it, like 12 years later from when I first started talking about, Netflix, they had their chaos monkey, which would go around and actually remove, disable services to make sure that the platform team could learn how it would react and adapt. And 12 years later, we're talking about artificial intelligence. Well, Netflix employs AI to enhance its CDN, or content delivery network, by predicting and analyzing viewer preferences and habits. And this allows Netflix to pre-position content closer to users in its cloud infrastructure, which ensures faster streaming speeds and reduced buffering times. As well as, in terms of dynamic resource optimization, it adjusts its cloud resource allocation based on real-time demand, viewer patterns, and content popularity, which means that they are scaling up resources during peak viewing times and scaling down during off-peak hours, which results in efficient use of the platform. Now, Azure, I wanted to bring this one up because I deal with data a lot, and one of the first things I realized that machine learning was making a massive making a massive change in the game, was around performance tuning on databases. And so the Azure platform leverages machine learning algorithm to continuously monitor database performance, identifying patterns and anomalies, and gives us feedback. And so this is off one of my UAT databases. I actually wanted to buy one that was not performing well. Sadly, mine are tuned so well that the Azure platform couldn't find any issues. So that's on me, not the platform. But we can get predictive insights for capacity planning. And back in the day, I used to scale my databases, and I used hyperscale, and I used AI in the background to determine how we would scale everything. Salesforce is another one where they employ AI-powered monitoring tools to preemptively detect and resolve issues within cloud services. So what they're looking at is pattern and trends in system behavior and user interactions, where they can predict potential disruptions, or more importantly, performance degradations before they impact end users. And this flows into load balancing across their cloud infrastructure. And so again, they're looking at application usage, system performance, where they can adjust resources to meet demand without over provisioning, because over provisioning means that we're going to be paying a lot more. And in fact, one way we can optimize our costs is with AI. I've written $2 million here to remind myself. So I worked with a client in September 2020, and they had about a $10 million spend in their cloud platform. And what happened was I used a whole heap of scripting at the time, and I managed to save them $2 million a year, or 20% of their cloud spend, by incorporating auto scaling, by incorporating machine learning to look at how their resources were scaled. Before I came on board and worked with them, they were manually scaling it up, and so that wasn't too efficient. But by have dynamic resource scaling, we could do it. And through continuous monitoring and analysis, we can identify underused or idle resources. And this was another area that I helped them save money. They had a whole heap of storage accounts that were a premium when in fact they didn't need to be. And by utilizing some of the AI resources within Azure, we could identify this wastage. And we had the ability to forecast out, and because again we're using predictive analytics to look at our future resource needs and associate costs based on historical data and usage trends. And so this means we can plan our budgets far more accurately, and also make informed decisions about, our investments in cloud architecture. Alrighty. Again, this is not a sales thing. This is around some of the tools that I really like. And my day, every day, is optimized by using Copilot within GitHub. I have the VS Code extension. I utilize it. And I also use Snyk in terms of checks for what I'm doing on what code I'm writing at source, on my computer itself. And this is really important because this can capture things right at the onset. So even before I am pushing my code to, my source control system, Snyk is looking at it immediately. And PagerDuty. So PagerDuty is a really good tool in terms of status updates, so that we can have dashboards that are showing how things are going. They utilize a whole heap of AI in the background that looks at incidences or problems, because if you have a whole heap of incidences related, well, that's a problem. ITIL 101. And PagerDuty is game changer in terms of grouping alerts together, analyzing it so that we can do faster remediation. And Azure, right? So Azure is built on top of AI and machine learning. I talked about Datadog. One of the reasons I may use Datadog is I may be using multi-cloud, and so I want that single pane. But even if I use Datadog, I will still utilize Azure Monitor and Application Insights in terms of analyzing a deep dive into my application and services. And of course, Azure AI services, my goodness, there is so much there that we can utilize. And I really do suggest that you look at Azure AI services. There is a whole heap of stuff there. Like, it's almost a whole day presentation, not even an hour presentation. Let's do the world's quickest demo. I know that we're getting near time. Cool. What I'm hoping is that you have, you can see visual code. So I have GitHub as an extension in Visual Code. What I'm going to do is I'm going to ask Copilot to write a function in Pulumi using TypeScript to deploy a storage account in Azure. And the thing is, I am proud to say that I have never written in TypeScript. I know that's probably something I shouldn't admit, but it's not. So I decided to choose something that I hadn't written in. And Pulumi is a deployment platform for developers, for the majority, to write infrastructure as code. But the really cool thing is, if I refine this and I want to say with variables, then Copilot will actually give me a better version of my code. And we're having one with variables that doesn't look exactly right, but that's okay. What I might do is get rid of all that and discard. And now I want it with variables and secrets. And what it's doing here is it's variabilizing what we have in terms of the code. So what I might do is find one of the good things about GitHub Copilot is it is my peer programmer. So I might have where I want to create a dictionary of 2-letter ISO countries. So I'm creating a data dictionary here, and you'll see here, it is creating on the fly my data dictionary. Yeah, and I don't care about that. Now, I'm going to show one last example of Copilot. This one is a game changer, and I'll show you why. So what I want here is for some table with order date and order total columns, I want to write a unit test. And one of the best unit test frameworks out there is T-SQL-T. So what we have here is a unit test written for SQL developers, DBAs, from the get-go, which is setting out the 3 A's, arrange, act, and assert, using T-SQL-T. It's actually done, one of the nuances of T-SQL-T is where we have to have a space between the word test and what we're doing. I don't know about you, audience, but that, for me, is amazing. Alrighty, that was the world's quickest demo. Here's the deal. In 2018, I circled the earth trying to get people to do unit testing for T-SQL, and it was so hard to get them to do it. You can do it in Visual Code with GitHub Copilot in seconds, and that is a massive, massive game changer for me. In fact, I won't go with that one. I'm sorry. So where are we going? Look, AI is going to help us move far faster than we ever have before. We will have autonomous operations and self-healing systems, and being able to enhance the way in which we provision our environments and also our tooling. I don't know about you, but I'm really, really excited about where our industry is going. You should not be scared about AI. It's not going to take your job. What it will do is make your job far, far better. You will be able to rise up to higher value activities and automate all of the manual toil operations that are holding you back and holding your company back from realizing the potential of efficient, reliable, and repeatable delivery of business value. Alrighty.
So,
If there are any questions, I'm happy to take them now. I know that we're close to time, but yeah.
thank you so much, Hamish. And I don't see any questions posted on the chat so far. Let me
That's
take
okay.
another look. Yeah. So thank you so much for your time. And it was
You're
an
welcome.
interesting session.
My details are there. Feel free to hit me up on Twitter or X with questions. Sometimes people, they see the content and then, a day or, an hour, a day, a week later, I often get people, email me or message me on Twitter, X, whatever. And I'm always happy to respond and reply because, it's been an absolute pleasure presenting today at Tech Day Pakistan, and I really do appreciate the honor of being able to present today. So thank you, everyone.
Yeah, thank you so much. And everyone, the session recording will be available on Tech Talk, Tech Day Pakistan YouTube channel soon. So if you miss anything, you will take it from there also. And you can reach out to Himesh on his Twitter and also on LinkedIn. Thank you so much.